Hello everyone, welcome back to Let's Unbound. We have reached the final part of our AP Precalculus One Topic at a Time series, Unit 1 playlist. In this part, I have combined the lessons 1.13 and 1.14 into a single session to wrap up the Unit 1. But that's not all. There will be one more special bonus episode coming up next. In that session, we will tackle an exam style problem from Unit 1. And I will walk you through how to solve it and how to present your solution clearly in an exam AP style exam format. So stay tuned for that. And if you haven't watched any of the videos before, so do save the playlist and watch it so that you will have a topic refresher. Entire topic refresher will be there if you started from 1.1 till this video. So for now on, let's dive into the final part of Unit 1. So function model selection and assumption articulation, function model construction and application. Let's go. What is this function model selection and assumption? So that will be a real world relationship, like a question will be given to you or a problem, a story problem. And to solve that, we will create an equation that is called function model. And you are just converting the real world relationship into math language, right? So which will be perfect, a linear, a quadratic, or a rational? So that will be done. That is function model selection. We will learn about it. And assumption articulation. This will be based on why this model makes sense in this area. So for this, you pick a quadratic model, why this works. So maybe it might be a trend of increasing, reach a peak and decreasing. So quadratic model, something like that. So, and also in our assumption articulation, I'm assuming the time is not negative. Of course, time is not negative. So these assumptions have to be made. Like there will be some constraints when we are doing in real life. In the pure math, I will say my quadratic function will working from negative infinity to positive infinity. But in problem solving, it won't be like that. So domain might have constriction, the constraints, and range might have, depends on the context. So we should able to assume things. Maybe one or more assumptions is possible. Now, function model selection. When a data is given in table, or they provide you a graph, or they give you a description, we will decide what type of function fits best. So here, some common general things. Linear will be suitable if constant first differences. You find the first differences, all of them are same. Quadratic if their second differences are same. Cubic if third differences are same. If you don't have any idea what I'm telling, please do wait. I will show you a calculation how this works. Okay, and rational when there is a restriction in asymptotic behavior. So this is how we will pick like some of the example cases. Now, here I tell you about differences, right? This is your independent variable and this is your dependent variable in a table of values is given. First, you have to check whether your the independent variable are equally spaced. Okay, so that is important. -5 to -3, 2 gaps. -2 gaps, 2 gaps, 2 gaps. So equally spaced, then it will work. Okay, yes, equally spaced. Now, first difference for y, not for x, you have to do all equally spaced or not. Now, first difference is like do it from successor to predecessor, or either way you can do. Anyways, it's going to be same, only the sign will differ. So this to this I subtract 98 and I put the first differences row 1. They're not same, so go for second differences, but you can see a symmetrical stuffs here, right? Row 2, yes, that is also not constant, so it's not fit. Quadratic model. So row 3, I got same. Even if they give some other, it might be same. So I will pick a cubic model for this. Because row 3 are same, then it is a cubic model. The third differences I need here. So this is how we will pick a model from table of values. Now, if you have these instances, like if your situation have a constant rate of change, linear function, increasing or decreasing rate of change, quadratic, like your rate of change is increasing, decreasing, okay? And 3 linear factors, if you are making something, you got 3 linear factors, of course it will result in cubic. If your variable appears in denominator, it might be rational. This is the situation and the suggested function type. Now, choosing domain and range restriction, this will come under assumption articulation. Okay, we will say why this model makes sense here, and some constraints also we should look upon, mainly domain and range. So real life situation rarely uses all real numbers, of course. Even it's quadratic, we know it's -infinity to infinity in math part, but in real life, it's not. if time is greater than or equal to 0, it cannot be negative. Height cannot be negative. Sometimes you can say a submarine is coming above, it can go below. So yeah, negative is possible there. Uh, so other than that, mostly it will be for height will be cannot be negative. Then physical limits also will be there. For example, your rectangle has an area of 40. Okay, so length and width you assume means you can't take till infinity, right? It will have some restrictions. So that is all the things we should look upon while solving a problem. Now, assumption articulation quick review. Justify why the selected model is reasonable. Model fit assumptions you can give in this way. So we assume why you are taking a polynomial model. So the data trend is continuous. It can be modeled by a polynomial. You got a two-factor thing. It become a quadratic in that way. Finite differences indicate degree. That we did, right? So finite differences we found, and row 1 means linear, row 3 means cubic, like that. Local validity of the model. This is also an assumption articulation. So for example, I said the rocket is projected and it fell down for sure after some time. Okay, so it won't work till infinity, 0 to some 10 seconds or something, right? For the short term of behavior, we will use the polynomial, maybe a quadratic function here, right? So these are the things. And now, okay, now you pause the video and observe this. A scenario is given. What is the best function model and what assumptions you can give here? Okay, right. Now, let's go. Steps to identify the problem. So first you understand the context. What are we trying? What is given? Read it twice and define the objective. What outcome we are aiming for? I need to find a height. What is this? Identify the variable, the unknowns and the knowns things. Gather all the available data from your problem. Identify relationships or patterns. So that is important. Then clarify limitations. Of course, real life problem will have some constraints. So if any error happens, so you can avoid those values. State assumptions if necessary. Assumptions, we already did this, right? So you can assume why the model is working, and you can take the domain where only your model will work. That alone you can, that interval alone you can pick. Correct. Now we are moving into question 1. A plumber charges a flat service fee of $50 plus $30 per hour. Write a function c of h for the total cost. State the domain and any assumption. So don't write f of x equal to. Go with the function name in a proper way. So first one is c of h. How they calculating the cost? $50 plus for every dollar, sorry, every hour it's $30. So 30 times h. The c of h means you should use h only as a independent variable. That's it. Function model is ready. State domain or any assumptions. Right? Let's say the domain is h can be greater or equal to 0. Okay. So this is because the hours cannot be negative, correct? Greater than or equal to 0. And assumptions, so you can take some assumptions like what does h usually measure? H represent hours, okay? So h is usually measured in a whole number or a fractional, like 2 hours or 2.5 hours, 2.5 hours, 5.5 hours, something like that. So they didn't mention only whole number of hours. So let's assume whole number or fraction. So it's a continuous. It's not like your graph will not be like 0 hour 50, 1 hour 80. It's not like having break. Okay, that is my assumption here. So because they didn't mention anything about it, so we are taking h is usually measured in whole number or also fraction. Or even in fractions. So we are assuming h is greater than or equal to 0 in a continuous string. And it will be linear function, right? So it might represent a line segment or a line. Continuous string. That's it. This is my assumption. And we are moving into next question. So very simple linear model question. Right? Okay. So question number 2. A rectangular garden is to be made using 40 meters of fencing on 3 sides. The fourth side is a wall. Let the width be x, write area as a function. Find the width that maximizes the area. State the domain and assumptions. Okay, we are talking about a rectangular garden. Okay. Fourth side is a wall. So let this be fourth side and this is a wall. So no fencing here. Correct. Let the width be x. So for my picture, it's x, the sketch. Okay. And what will be the length? Okay, the total fencing part, I'm using a 40 meter like of the material. So this would be 40. I use x and x here. So 40 minus 2x will cover the length part in fencing. Okay. Now, how can I write area as a function? Area is length into width. I have length 40 minus 2x. They give the width, it's x. This is enough, or you can represent in factored form or standard form. That will be the best, I would say. So you can let's take minus 2 outside of it. You will get x minus 20. Okay, and also let me write it in order. Minus 2 x minus 20. This is the a of x. Okay, try to make it in single variable. It will be available. The data will be available. Just you have to make a relation between them. So first part is over, right? Now find the width that maximize the area. Okay, let me do here. So this is my a of x. So minus 2x, x minus 20. It will, okay, you can see the leading two factors, so quadratic, leading coefficient negative, it's downward facing quadratic. Which x will maximize this? Exactly midpoint because it's symmetrical, right? So width that maximize area. So your every point on the parabola will be x comma a of x, correct? So maximum means it will occur at the vertex. How can I find the vertex? That's it. If you find vertex, and also not complete vertex is needed, you can just find x. You just need the x coordinate. When in factored form, the vertex will be exactly at the midpoint. So find the midpoint of the factors you can see here. So x means 0. X minus 20 means 20. So the midpoint is 0 plus 20 by 2, 10. So something 10 comma something. So with that maximize the area is 10 meter. Okay. You even give 11 meter, it will be less than 10. So 10 is the dimension that will maximize the area here. Okay. That's it. Now, third part is state the domain and assumptions. Okay, this is my area function. Wait a moment. Yeah. A of x is minus 2x, x minus 20, domain. Very important. X is width, correct? So x have to be greater than 0. Okay, even equal 0 you won't take here. 0 width, no, it will become a line, correct? So x is greater than 0 strictly. And can I take till infinity then? No. So your width should be greater than 0. Your length also should be greater than 0. What is the length expression? I want domain means I need in terms of x. So length is, let's go back and check. 40 minus 2x. So 40 minus 2x should be greater than 0 strictly again. And solve this inequality. Subtract 40 on both ends. You will get my negative 2x is greater than negative 40. Divide by negative 2 and x. Flip the sign because I'm dividing by negative number 20. So your x is greater than 0 but less than 20. So between 0 to 20. Okay, this is the domain. The width will lie between. So this is the restriction. Now, that's a domain. Now, assumption. How did you get this domain? That will, by assuming something, right? That assumptions you need to list it up in your own words. So you can write length and width both are positive. Even 0 is not allowed, okay? Length and width both are positive, so we applied it. And we got a result like domain. And here also, you can take 1.5, 1.2, 0.01, right? Any length can be measured even, so it's continuous. So that also you can mention. Real and continuous values are allowed. Continuous values in trend or allowed, something like this you can simply mention your assumptions. Okay. So that's why I'm giving an interval notation, not like listing numbers. Okay. That's question number 2. Now we are to the last question, question number 3. A box with no top is made by cutting equal squares of side x from each corner of a 30 centimeter by 20 centimeter piece of cardboard and folding up the sides. Write the volume as a function of x. find the value of x that maximize the volume. Actually, we can find the interval where the x lies. Okay, not exactly confined, but we can approximate it. State the domain and assumptions. Okay, let's understand the problem. A box with no top is we are making like a baking tray. And how we are making it? We are cutting it from a cardboard, which is 30 by 20 centimeter. So 30 centimeter, 20 centimeter. We are cutting the corner, cutting equal squares of side x. So in this corner, I will cut a square of side x. Here, I will cut a square of x. So length with x. Everywhere, I'm doing the same. What will want? Okay, here, x. Every corner. And after cutting, let me make it dotted line. If you fold these dotted lines, you will get a 3D shape, kind of a baking tray, correct? And the 2D become 3D after folding and cutting and folding actually. Now, you make a box, open, no, like open top box like this. So what will be the height and what will be the length, what will be the width? So this part will act as a height. Okay, so the height is x. Actually, we should start from length, but anyways, height is x. What is length? The longer position, the longer part, like 30. Height will be the like 30 and 2x had been cut, right? So 30 minus 2x. And your width, we can write here. So with this, again, 20 minus 2x, the whole 20, we cut two parts. So this is a situation, we got the box with no top and its dimension in terms of single variable. Now, first question is, write the volume as a function of x. V of x is length into width into height. We have everything. Our length is, here we go, 30 minus 2x. Our width is 20 minus 2x. Our height is x. And factored form is okay. Or you can convert to standard form. How will you like? You can simplify the factored form actually. Take 2 from this, 2 times, actually negative 2 from this. You will get x minus 15. And here also you take negative 2 outside. X minus 10 and into x. So negative 2 into negative 2 is 4x, x minus 10, x minus 15. So perfect factored form we did. Right. So this is volume of x and we did this. Find the interval where the value of x lies, that x will maximize the volume. So volume need to be maximized. Okay, parabola means easily we can find the vertex is maximum, but let's understand how this cubic model is working here. Okay, so wait. Yeah. So let's plot it. What are the x-intercept? It crosses 0, then it crosses 10, then it crosses 15. It's a cubic function. And leading coefficient is positive, correct? The leading coefficient is positive means an odd and positive leading coefficient. So right side up, left side down. Okay, so I'm making a trend like this. It should cross this, right? So it should go. And again, it should cross means it should come down. Again, it should cross 15 means it's go up. So this is how the model in graphical, like it's just an assumed graph, right? It can be like this, but not exact, just a sketch. Yes, maximum is possible, minimum is also possible. I can see the trend in the graph. So in which interval does that maximum lies? Between 0 to 10. It's not exact middle, but somewhere between 0 and 10, right? So we can answer this question. So maximizing values, it relies on the interval, the width that maximize v of x lies on the interval 0, 10. That is our answer, final answer. Okay, now what is that part? State the domain and assumptions. Yeah, we have analytical form. Let's make domain and assumption. Actually, in this model, we can't go for the left side of negative, right? So just it's a model. Okay. Yes. Into the last part, and it is about domain and assumptions. So domain, what is your v of x? 4x, x minus 10, x minus 15. How will you assume domain? Your length, width, height, everything is greater than 0. So don't take this is length, width, height, okay? So what we assumed in the original sketch, 20 minus x, 30 minus 2x. I mean 20 minus 2x. So x should be greater than 0. 20 minus 2x should be greater than 0. 30 minus 2x should be greater than 0. And when you solve this, minus 2x greater than minus 20, which gives x less than 10. And this says minus 2x greater than minus 30 and x less than 15. Okay. Now, so greater than 0, less than 10, less than 15. Let me mark and pick the common interval. Greater than 0 means everything after this. Now, less than 10 means you can't exceed 0, right? So, this way. Less than 15 means, like this is 15, or let me do here, 15 to this way. Where all of the three intervals meet up. That's the common part, so 0 to 10. So, your x should lie between 0 and 10. Strictly don't include this. Okay, if you include 10, volume can become 0, and also length and width, they may be 0. So 0 less than x less than 10. Okay, strict inequalities, this is domain. And assumptions, I think you can do it. Many assumptions here. I'm giving a list of assumptions. First one is, you can note it, the thing, how I find domain, that assumptions. Dimensions cannot be negative. So I used it for my assumption purpose. Dimensions can't be negative. Also, it can be 0. So I can say non-negative. Non-negative means what? Wait. Cannot be negative. Cannot be neither negative nor 0. 0 is also not allowed, right? So if we put negative, it might it will convey 0 is also possible. So let's be more careful. Dimension can't be neither negative nor 0, or either negative or 0. Now, when we are looking on the cardboard, there might be a chance if it's a heavy, thick material, it will be a hollow cuboid. So that we should consider. Some of you might think about it. So a negligible thickness of the cardboard, very negligible thickness. If it's like like 12-inch thickness means it's completely a different scenario. So negligible thickness. Negligible thickness of cardboard. Okay, we didn't consider the thickness. So we just ignore that. There is no thickness. We assumed it, they didn't give. And we are cutting and folding and no material loss on it. Okay. If that they didn't mention that, but we assumed it. Okay. These are some common assumptions that we can make out. And the bonus question for you. A tank is filled at a constant rate of 120 liters per minute. The concentration of a dye in the tank is given by this equation model. Why this is a rational model? What is the domain? What assumption is made about mixing? And what happens to C of t as t tend to infinity? Okay, right. So that's the bonus question for today. And now it's a thank you time. So thank you for joining and learning with us. And I will be meeting you in the exam style problem solving video of purely unit 1 based question. So stay tuned, keep learning. If you have any thoughts or if you want to share your feedback, you can drop them in comment. Thank you. Keep learning, keep practicing.